Hello, this is Mr. Doro. This is a video tutorial about matter and change. Today's objective is that students going to be able to think about matter as a collection of particles and determine different aspects of the arrangement of those particles. That picture of the fire that's burning right up there, that has a lot of matter in it and a lot of matter that's going through changes. So we know that there's matter all around us, but we need to know what that matter is made up of. I have three pictures right here, and this is a penny, which we know has copper in it. This is copper sulfate, which is a copper-containing compound, and the Statue of Liberty is made out of copper, although it doesn't look like the penny. It's green because it's oxidized. That means it's reacted with oxygen. All matter is made up of elements from the periodic table. It may seem almost impossible that so many different types of matter can be made up from this few elements, but if you think about our alphabet, only has 26 letters in it, and yet it can be joined together in so many different ways to make different words. There's also a picture of cows here, and the cows have something to do with copper too, because copper sulfate is used a lot in agriculture. And so copper can be used a whole bunch of different places, and that's just one element that's on the periodic table. When we look at these, we might say, oh, they all have copper in them. But we need to make sure that we're starting to think on a particle level when we're talking about chemistry. Not only what we can see, but deeper down than that, inside what we can see, what are the particles that make up that thing that we can see? When we start thinking on the particle level, we start to think about atoms, elements, molecules, and compounds. To get a little better understanding of these, take a look at this first picture right here. You can see that in this picture, all these particles are the same color and they're not joined together. This picture represents, all together, this represents an element. Because it's made up of all the same type of particle and they're not joined together. Now individually inside this element, one of these little guys right here, it would be an atom. So you can see that if you have a whole bunch of the same type of atom all together, it all makes up an element. Elements are made up of one or more of the same type of atom all together in the same place. So if this were copper, like we had on the front page, this would be the element copper, and it still would be the element copper even if you cut it in half right here, because it's made up of a whole bunch of atoms of all copper. On the other hand, this picture down here on the bottom has two different types of particles that are joined together. That's why it has the red and the blue, and you can see that they're touching each other in the same order each time. That means that they are chemically joined together. All this whole thing makes up together a compound. And within the compound, if we were to single out just one of these, right here, we're just going to single out one of those joining together. That is a molecule. So again, we could cut this in half and we still have the same compound, we just have less molecules. You can have a whole bunch of molecules to make up a compound, so molecules make up a compound, atoms make up an element. So these atoms, elements, molecules, and compound, this is what all matter is built on. They all are either made up of atoms or molecules. When we're talking about properties of matter, there are a couple of different things that we could talk about. We could talk about physical properties, or we could talk about chemical properties. Physical properties, you can measure those and they don't change or observe them. They don't change the identity of a substance. Here's some examples. You can measure the mass of a substance, like a hunk of lead, and if you found the mass of that hunk of lead, you didn't have to change it to find that mass. Or you can measure the volume, you can measure density, you could measure the color. These are all physical properties of matter. But when you do you're measuring a chemical property, it is how it reacts with different things or goes through changes to transform into a different substance. Those examples of chemical properties would be things like flammable. Now you can't find out if something's flammable unless you light it, and then you've changed, if it is flammable, it changes the identity into a different substance. Or explosive. Or somewhere like reactive. Those are chemical examples of chemical properties. Going along with those physical properties, there's also intensive and extensive properties. A couple big words, here's what they mean. Extensive property is where it depends on the amount of matter present, so that will change depending on if you have more or less of it. Things like, again, mass. If you have more of the matter, then it's going to have a greater mass. Or volume, those kind of things change with the extensive properties. Intensive properties depend on what's inside of it. Now, interesting is density. Density is an example of an intensive property, and also things like reactivity. And I like to think of them as intensive property, reactivity, is what is based on what is inside of whatever the matter is. Matter can go through different types of changes also. One type is a physical change. In a physical change, you're changing maybe the arrangement of the particles or just the looks of the matter, but you're not changing the chemical makeup of it. For example, I have here a picture of an iceberg, and it's in the water. And so we have actually three different forms of water. We have solid water, where it makes like a crystalline structure. They're all joined together. That's the ice. That is actually solid water. This is liquid water, where it still has H2O molecules, but they're a little more free. They can flow past each other. And this is water vapor up here in the clouds. Still H2O molecules, but they are spread further apart. Here's another look at states of matter. This top one right up here, we have an element, and I know it's an element because you can see that in this gaseous state that they are just the single particles or the single atoms. They're not joined up with anything, so it's not a compound. And so this is the crystalline structure, which is going to be your solid. And then in order to make it go to a liquid, we know that we have to heat it up. When we heat it up, these start to break apart from each other and are able to flow past each other more. And we heat it up more, and we could have that same substance in a gas. So solid, liquid, and gas. This is oxygen. O2 is a molecule because it is two oxygens joined together or bonded together. And this is, you could have solid oxygen under the right temperature and pressure conditions. And so in this container, that solid oxygen is all tightly packed together. And when it's liquid oxygen, and you could have liquid oxygen also, it doesn't last long in our temperature that we're normally in the rooms. But that liquid oxygen is able to flow past each other. And the gas, you can see that they're far spread out and moving around quite a bit. Next, we have a chemical change. Chemical change, you end up getting a new substance. So this picture right here has on this side over here what you started out with. And so we had hydrogen, which is, this is, as you should know now, a molecule because it's two hydrogens bonded together. And we have chlorine, Cl2, and they're just in the same area right here. They're not bonded together. But then afterwards, something happened, and you can see that the H's bonded with the Cl. This is a new identity, a new substance that is being made, and so the H2 and the Cl2s join up and they make HCl. And so this is a example of a chemical change. There are chemical changes that go on all over the place, and you guys have seen fireworks before. Those are chemical changes where they are becoming a new substance each time. So that brings us to a substance versus a mixture. Substances are also called pure substances. That's why I have this in parentheses right here. A pure substance is matter that has its own identity. Now, a pure substance can be one of two things. It could either be an element or a compound. And we know that that could be an atom also then, or a molecule within those, but in order to be a pure substance, it has to be an element or a compound. Compounds always have their own chemical formula, like water, H2O. That is the formula for compound. You can never have H2O2 and have that as water. That's hydrogen peroxide, and that's quite a bit different, has different properties. Now, a mixture is two or more substances that are in the same area. So down here on this picture, you can see that we have, and you should be able to tell now that this is a compound. This is a pure substance because they have their own identity here. But now we have a mixture, but this is the important part right here. Notice that in the mixture we have a couple different pure substances. This is an element. That says element, believe it or not. And this is a different element. And so a mixture is two or more pure substances just in the same area, but it's not the same all the way throughout. You could also have two types of mixtures. Mixtures can be heterogeneous, which is on this side right over here, or they can be homogeneous. Now remember, Just because they're homogeneous, which means the same throughout, does not mean they're bonded together, but you can see that they are evenly dispersed all the way throughout. And this is heterogeneous. They're not evenly dispersed. You've got the different type of elements down here, and you've got the purple ones up there, but this one, they are evenly dispersed all the way throughout there. That makes it a homogeneous mixture. This would also be called a solution. If you have a solution of something, it's evenly dispersed all the way throughout. Here's a little chart that can help you classify matter. If you start out by asking these questions over here, first of all, does it have uniform properties? That means it is the same throughout. If it does have uniform properties, we're going to go down to this next one, but if it doesn't, we already know it's got to be a heterogeneous mixture. So I'll be asking you some questions about some things that you see around in your daily life, and you should ask that, is it the same all the way throughout? If no, it's got to be a heterogeneous mixture. Then does it have a fixed composition? Like, does it have to have a certain way that the formula is written? Like water is always going to be H2O. If it does not, then it would be a solution. Now, a solution, you know, like when you make lemonade, that you can make it stronger or weaker each time. And so if you add more lemonade powder to it, then it's going to get stronger. Sorry for those of you who like fresh squeezed lemonade. All right, or if you add more water to it, it's going to get weaker. That would be not a fixed composition. And so that means it is a solution or a homogeneous mixture. Is it chemically decomposable? Can it break down is what that's asking. So if it's uniform, it has a fixed composition the way it has to be chemically, but can it break down? If it can't break down, it has to be an element. And I don't really care for this picture that's on here. I would rather see single dots on there. And if it can break down, then it has to be a compound. And so you can see that there are different colors that are joined together on that. So here's what I'd like you to do. I'd like you to take a look at all these pictures, and I've got them numbered 1 through 11. I've given you gas, liquid, and solid pictures so that you can look at how the particles are arranged in each one. And I want you to first of all tell me, from those particles, is it a substance, which is a pure substance, or is it a mixture? That's the first thing I want you to tell me. And then, based on that, I want you to tell me whether it's element, compound, homogeneous, or heterogeneous. Here's a helpful hint. Substance is only going to be either element or compound. So if you say it's a pure substance, then you got to determine then, is it an element or a compound? Mixture is going to be a homogeneous or a heterogeneous. It could be a mixture of elements or compounds, but it would be a mixture of different pure substances. So make sure that you have these written out and have a good idea so that we can go through them in class. Have a great day. Bye-bye.